Examining the light clock argument. The light clock is one of Albert Einstein's thought experiments. It consists of a pulse of light that is bounced between two mirrors. One return journey, up to the top mirror and back, is one tick of the clock. When the clock is moved laterally, it will seem that the light must travel further, diagonally, between the mirrors. Pythagorean mathematics can be used to calculate the apparent difference in distance traveled by the seen light, according to a stationary observer of the moving light clock system, compared to distance when it is seen to be stationary. The distance between mirrors of the material clock is known, as is the distance translated. Using these measurements, two right-angled triangles can be formed, and the length of the hypotenuse representing the diagonal path can be found. To go further at the same speed of a light, in one clock tick, the time given by the ticks must slow down. From this argument comes the saying, moving clocks run slow. For the material clock, the distance between mirrors does not change, so the tick distance stays the same, and at the speed of light the period is the same. A component of the translation should not be added to the tick length. Pythagoras' theorem is not applicable when considering the material reality of the clock. The period of the electromagnetic radiation and the period of the clock tick are mathematically invariant under translation. Electromagnetic radiation is bounced between the mirrors, which needs to be differentiated from the seen light beam phenomenon. The unseen electromagnetic radiation is an object reality actualization. The seen light beam is an image reality manifestation. The object reality. A co-moving observer, moving together with the moving clock, will have an unchanging relation to the clock and so only thinks about the light beam's vertical motion, as does a stationary observer of a stationary clock. Whereas for a stationary observer of the moving clock, the distance between them changes because of the translation motion. What is happening in the clock? There is one source reality. The electromagnetic radiation must be traveling the same distance between the mirrors, with the same speed and period, giving the same number of vibrations and ticks, in all of the scenarios mentioned. Remember, this is not what is seen but what is happening in an imagined material light clock. Concerning the vertical motion of the electromagnetic radiation, the mirrors are always an equal distance apart and not displaced in material object reality. A diagram of a diagonal path between displaced mirrors is never representing a unitemporal object reality. As the configuration of object reality changes, the vertical motion of the electromagnetic radiation pulse between mirrors is sequentially distributed along the horizontal direction of translation, as the electromagnetic radiation moves, if the translation is considered. This does not mean that the electromagnetic radiation has taken a longer path between the mirrors when the translation is taken into account. When just mathematics is considered, period is invariant under translation. The magnitude of the cycle does not change, so at the same speed it takes the same time to complete that cycle. Consider one tick of the clock as one cycle. Compare with one full rotation of a mark on the rim of a jacked-up wheel. Then consider, as the lowered wheel rolls along the ground, the circumference stays the same. So too for a jacked-up wheel rotating at the same speed on the back of a speeding lorry. So the cycle is the same, and at the same speed of rotation the period will be the same. A component of the translation is not added to the circumference. The wheel rotation cycle distance is independent of the amount of horizontal translation of the mark and the length of the arcs of its motion, taking into account both periodic and horizontal motion. This explains why the speed of light on a speeding train is still just the speed of light. The period of vibration of the light is unaffected by the translation. The different kinds of motion, the periodic motion and translation motion, must be treated independently, not added arithmetically or as vectors. Now let's consider what is seen. Image reality. To be seen, electromagnetic radiation must reach the eyes of the observer. So the central nervous system can generate an image, observation product, or reach the photoreceptors of a device used for observation. The electromagnetic radiation bouncing between the mirrors does not reach the observer, so isn't seen. Electromagnetic radiation scattered from the pulse does reach the observer. The image reality generated by the observer is not the object reality occurring inside the clock. The same interrelation would apply if instead of vision the observers used the sending and receiving of radio signals from clock to observer. For the stationary observer of a stationary clock, and a co-moving observer of a moving clock, the relation of observer to clock is constant. It always takes the same length of time for the electromagnetic radiation to travel from light pulse source to observer. For the stationary observer of the moving clock, the relation is changing. As the clock moves further away, it takes longer for the scattered electromagnetic radiation to reach the observer, according to distance. Each observer makes their own observation products, using the electromagnetic radiation received at their location, which depends upon their and the clock's relative motion. No paradox. Adapted from The Right Time, a book by Georgina P. Woodward. Narrated by AI voice Beatrix of Speechelo.